Clark, thank you for taking the time out to chat with me.
Thanks.
Hope you're enjoying the Hack Seasons conference and just overall Singapore Token 2049. How's it going for you?
Singapore is awesome. I've been basically just going around to all the hawker centers and eating as much as I can. I'm afraid I'm going to go home several kilograms heavier. The other thing is Formula One's here, so that's pretty awesome.
Yeah. Did you have a chance to go to any events?
I think practices start tomorrow, but I mean maybe that's not the maybe that's not the reason we're here. But I did want to tie in, right? I think the title for this talk is totally wrong, just 100% wrong. It says how to successfully build your AI project. Now, that's not what I'm talking about. I'm just gonna torpedo this. What I want to tell you about is how to not fail. Okay, so there's two things you really need to know. Like, I'm my local soccer commissioner back in Chicago, and I'm a coach of my 12U team, and I tell them there's two ways to win a soccer game. There's score more goals or give up less goals. And the kids are like, well, that's the same thing. I'm like, it is not the same thing, right? So if you've been trading stocks, you have to just survive, right? The market can stay irrational longer than you can stay solvent. So the point is, what I want to tell you about is how to not fail. Now, since we're here in Singapore and we're in F1 week, I do want to sort of set the stage with this quote, right? I'm going to attribute this to Garth Stein in The Art of Racing in the Rain, but more particularly to the dog protagonist in The Art of Racing in the Rain. He says, I'm not going to do the dog's voice, but he says, you can't win a race in the first turn, but you can lose it there.
Yeah, I concur.
Right, that is the whole point here. So in AI projects, you want to survive long enough to actually do your AI projects. Okay, so maybe I keep going. You want to ask some questions? We can do this.
I actually want to get into your background because I think it's quite phenomenal, and the audience should hear more about it. As we talk about the four different branches of physics, you have general relativity, quantum field theory, quantum mechanics, and I'm forgetting one of them.
I would call it thermodynamics, but it's in the realm of quantum. But classical mechanics, electricity and magnetism, all these.
Yeah, all these different things. I guess, how does this tie into the AI and crypto context, specifically within the quantum computing side of things?
Right. We'll get to the advertisement in a little bit, but one of the things I work on a lot is quantum computing and quantum cybersecurity. I actually am on the IEEE committee for international quantum cybersecurity. We're about to put a paper soon. But we are aiming to be one of the only, if not the only, post-quantum secure blockchain.
Yeah. And I guess with quantum computing becoming a more and more pertinent topic as we're able to pack more qubits into these machines, what are we able to unlock with all this new computing power?
Not much. And that's going to ruffle some feathers, but I'm going to keep this as simple as possible. There's maybe I go back to my question that I really like to talk about. I've told several people this today, but I was in Egypt a month ago for the National Quantum Hackathon, and I started my talk with this question. So you can think about it for a second. Everyone here, first, anyone here like Legos? Okay, several people and others not paying attention. Fantastic. Okay, so if you like Legos, which is everyone here, except for those not paying attention, I want to ask you a question. How tall can you build? What's the tallest Lego tower you could build? How tall can you build this tower? Right? And the answer is, there's two answers. There are two answers, and the first one is this. The math answer is stick them together forever and ever, and it just goes for infinity. Right? Easy enough. No obstructions there. The physics answer is gravity takes over, and this building will collapse at some point. Can you build it to the moon? I don't think so. I think there's a limit. I don't know what it is exactly, but they're not the same thing. Okay? Now, in compute, one of the really important things that I like to really try to emphasize is that there's a math answer to a lot of computing problems, and then there's a physical barrier to a lot of problems, right? AI, where I work, a lot of the times, there's this massive physical barrier about the amount of energy you could actually use, right? So this actually precludes us from getting AGI via the LLM models. It's not possible. The energy plateaus.
So then I'm kind of curious then, how do you balance, kind of tying it back into discussion slightly, how do you balance perfection not being the enemy of done, or saying what's practical versus what's ready to ship right now? Because there's no perfect time to do anything.
Correct. Basically, you want to survive to fight another day. And that's kind of the point. You don't want to lose in the first turn. You don't want to lose your race there, right? And there's a couple things that we could talk about, right? Don't be too aggressive too early, right? That's if F1 fans will have seen that this happens a lot. And then there's a couple other interpretations we can do of this, but basically your goal is not to fail. I don't know how to say this any more clearly, but I'll give an example of where I see a couple of failure points, really strong points in building AI. So it's not successfully building AI, it's not building. One thing is to say, don't pick your tech stack before you have solved the problem. Just don't do that. Don't do this. What you're going to end up doing, 100% doing, is fitting square pegs into round holes. That's what you're going to do, because you're going to say, oh, I don't have enough parallelization. I have too much parallelization. My GPU usage is idle all the time, which is part of what we're trying to solve, this idle GPU usage problem. So maybe you do want to set the tech stack first so that it benefits my company. We're going to take advantage of that. But what you end up ending is like you have to like reformulate your problem to either like you found that someone else wrote a wrapper and then you have to like solve someone else's problem. Well, that's another issue, because the problem someone else solved isn't your problem and it isn't your customer's problem.
Yeah.
Right? You can't just copy it word for word. That opportunity, that solution is gone. You have to do something else.
Yeah, so if we're focused on not failing, kind of want to touch on one of the points you just made, is it more so about timing the market or time in the market?
Yes. Right? It's kind of both, right? Timing the market is really, it's impossible, right? I've traded stocks, I've traded electricity. Timing the market's really hard. But you know, the strategy is to sort of diversify it, right? You want to diversify what you're in the market to do. I think that Nassim Taleb actually says this really well in Fooled by Randomness. You're in the market and most of the things are going down, but if you're in the market and one of these things pops up, you have to be there to grab it. You have to like actually be in the market to grab that opportunity, right? So you have to set it up, but you have to survive long enough to get that opportunity there, right? You can't time it. You just have to be ready if and when it shows up.
Well said. And I guess now to take that and tie it into a personal anecdote, what's the biggest risk you've ever taken as an entrepreneur?
Starting a company. Starting a company is a massive risk, right? But you know, I didn't for a long time because I just stayed in academics, and academics like prevents you from making big money, right? I wanted like to do the research and all the things, and right. So there's always a related risk and payoff, whether you stay in academics and don't get the money, or you go like try it in the market and you get the money, but maybe you fail.
Yeah.
Right. So there's got to be some sweet spot of your risk reward.
Yeah, and I was going to say, with respect to risk reward, what's been the most rewarding experience in just not failing long enough?
Okay, so let me tell you a couple of things that I have worked on. The idea is that since I'm a mathematician, right, a mathematician and a physicist, I see where the problems that I solved abstractly when I was an undergraduate, when I was doing my PhD, show up in industrial mathematics, and a lot of people aren't there to see them. Right, so one of the very first things I did is I went back to like nuclear physics and I said, oh, this is how you tell a data set is corrupt. And everyone was like, what the hell are you talking about? And I was like, yeah, it's just some eigenvalues, whatever, some technical nonsense. But that worked really well because we actually found a customer had manipulated some data. Oh, wow. It was one data set, but like that was a really good find because it was going to cost us some money. Understood. And we didn't. We caught it. We caught it because I built this like, I was just looking at it in a way that only I knew how to do it, because I didn't know how to do the traditional stuff, right? So, you know, you set yourself up to diversify. Now, bringing into Argentum AI, one of the things that I'm excited about this particular project is that, you know, before we're talking about decentralized compute, which is awesome, and I think this is one of the many ways that we're going to really advance computing, but the AI is not the only focus we have. We've built an AI that sort of helps navigate auctions. But the users on our platform should be able to train an AI model, but also do any like really heavy numerical compute thing. Okay, so look at visual graphics. There's a big market in video game industry. There's a big market in movie industry. Optimization, that's massive, and I'll talk about that in a second. A friend of mine, we're trying to get on to do molecular simulations, right? So drug discovery, right? Drug market in the States, not a small market, not tiny, large. I don't have arms long enough, but drug market, that's big. Yeah. So this is just from using idle GPU time. I'm idolizing GPUs. That's not at all what I meant to say. The big one, though, because I'm in energy, the big thing, this problem, this is the most important, most valuable problem you've never heard of, called the ACOPF. Have you heard of this?
I have not.
ACOPF, anyone except for Nick, because I already told him? Perfect, okay. ACOPF is alternating current optimal power flow. This is the most difficult problem because it's got every type of mathematical obstruction that you could actually solve. But on the back of the envelope calculations, a 1% improvement that you're able to successfully trade on is worth $1 billion a day.
Yeah. This is kind of like with respect to Markov chains. If you're able to see just even slightly forward in the future ahead of your competitor, that's worth that
improvement,
much.
Right.
Yeah.
So energy markets is something I'm personally interested in using the idle GPU time to like run some ACOPF models for my personal use. I mean, within the company, but what I'm trying to say is like what we're trying to build out is like a very widely diversified set of problems that are able to be addressed just by using someone else's idle compute time. I'm not just focusing on AI. I want to diversify that market. So if something comes up, a drug discovery, we have to be there to grab it. Right? That's kind of the how to not fail. Don't build a thing before you've solved the problem. And also like diversify. And there's no universal prescription for how you actually do this, right? I can't tell you like, hey, Kelvin, you should do this X, Y, and Z thing because that's probably going to make you fail because your problem's not the same as my problem. You have different customers than I have, right? Your customer might be you.
Yeah.
So your individual problem is not the same as my individual problem that you want to solve. So, I mean, that's kind of the two things. Don't lose in the first turn. And like diversify so that you can be ready to actually take grab the market when it pops up in your advantage.
Understood. And as we talk about like kind of tangential financial mathematical topics, someone who comes to mind with respect to AI and finance is James Simons. I'm curious what you think he would think about the current state of finance and the opportunity that lies ahead with AI and financial markets, and specifically maybe even crypto rails. He seemed like a guy who wrapped his head around it. I think Millennium was buying Bitcoin pretty early on.
Yeah. I mean, Jim Simons was actually the thesis advisor of one of my best friends from undergrad.
Really?
Believe it or not. And I talked to Steve Daffran a little while ago, who was the COO of Renaissance Tech, and we were talking about, how quickly and like the efficacy of picking a stock portfolio quickly, so that you're not paying for it in time and volatility. But my understanding is that in these financial markets, Jim Simons basically was just hedging. Like the Man Who Solved the Market, they said the Renaissance was right 50.07% of the time, and they're the most successful hedge fund that ever existed.
Yeah.
Right. So this much, but it was just hedging and like leveraging the trades that you've made. One interesting thing that I think we're going to start seeing is derivatives trading on cryptocurrencies, not just on the ETFs of cryptos. I think that's going to be one of the points at which the crypto market really rises.
Understood. I guess the next thing I'm kind of curious about would be, as you talk about the problems that we're able to solve, scaling. How do we think about scale now that we have access to, or that you have access to other people's compute and resources that would have been wasted otherwise?
I mean, again, let me go back to the diversification, right?
Yeah.
If I'm going to say, what do I really want to mark as a benchmark of success for this particular project? Right? From my point of view is that I want big and little players on both sides of this coin. I want little players who need a little bit more help in running an AI model, or someone doing an optimization scheme, drug discovery, and I want on the other side someone like Kelvin, like, can I borrow your computer, right? Just run some extra time. I don't need it tomorrow morning, but I also want like some big players who are running like weather predictions, right? So for me, a big win is to diversify this out on both ends, the users and the providers, so that we can like really solve. I want to see a lot of problems actually solved on our chain.
Understood. And on the topic of diversification, it's interesting how you're going to enable small guys access to just more compute so they can solve maybe things that would take them a long time. How do you think about greenfield problems with respect to like things like incomputable numbers in the fields of like computer science and mathematics?
Anyone ready for a philosophy lecture?
Yeah.
They've gone back to their phones. That's okay. Lego fans? Lego fans? Just a few. Okay. I actually gave this litmus test. One of my litmus tests for whether we will achieve AGI it comes right down. It's the same question here. Can a computer solve a problem for which there is no amount of data? All right, and we just have like a lot of questions just simply on integers. If a computer can do that, where you can't possibly feed it all of the integers. There's no possible. It's not physically possible. It's not even mathematically possible to feed it all the integers and just check. So you have to have some other clever solution that it's actually doing. This is a litmus test as if we're going to achieve AGI.
Yeah.
Right, so
Understood.
greenfield numbers, it's this sort of idea. I like Collat's conjecture because it's easy to explain to kids.
Yeah.
But
Got it. So now to tie it back to the audience, when they think about how they can scale what's possible, how do you think about like resourcing when building these projects? If you have access to just higher throughput systems, I mean, people are still going to be necessary, but it does change team dynamic. It changes team dynamics overall.
tremendously. I mean, I think I'll give a good example of what we were talking about in the tech building meetings early is when you have these bursty problems. A lot of problems, you don't need the compute running at full tilt all the time, right? But you're going to have just like this really big burst if you need a lot of GPU compute for like 35 seconds. So if someone, a good friend of mine who has a massive computer at home, he's not using it anymore because he built it for a previous job. Well, it's like, well, I've got like eight free GPUs, like with like 35 cores. Yeah, you could borrow it and just pay in. So going back to the scaling question, right, I want to have the scale where you can do it small or you can do it big, and the diversification you have like a bursty model or something that just kind of needs to run for a long time, like a language model where you're trying to train it. So any of these, I think are sort of in scope of what we're trying to look at.
Understood. Selfishly, I would love to continue, but I am getting the hook. That being said, Clark, certified GigaBrain, thank you very much for the time.
Thank you,
Appreciate
Kelvin.
it.